Welcome to the Western Regional Laboratory of the Bureau of Indian Standards. In the light of growing emphasis on the quality and safety in the Indian manufacturing industry, there is a critical need for comprehensive resources that elucidate the process of product testing according to the Indian standards in the form of videos on testing of products. The purpose of this video from BIS is to facilitate industrial professionals, to educate consumers, to aid educational institutes, and to support stakeholders.
BIS has established a network of state-of-the-art laboratories across the country, and Western Regional Lab Mumbai is one of them. At BIS Labs, we carry out testing of various products as per the test methods given in Indian standards, thereby ensuring that only products with the right quality reach the Indian consumers. भारत देश को एक गुणवत्ता सचेत राष्ट्र बनाने के लिए हमारी प्रयोगशालाएं हमेशा तत्पर हैं।
In this video, we are going to demonstrate the various tests performed on the PVCU pipes used for soil and waste discharge systems in accordance with Indian standards. A robust drainage system is vital for maintaining hygiene and preventing waterlogging in and around buildings. An efficient system ensures seamless discharge of waste and rainwater. PVCU pipes are a preferred choice for modern drainage solutions. Made from unplasticized polyvinyl chloride, these pipes offer excellent durability, chemical resistance, and smooth interiors that prevent clogging. Their rigid, lightweight structures makes them ideal for soil, waste, and rainwater discharge systems.
PVCU pipes are widely used for soil and waste discharge systems inside and outside building, including ventilation and rainwater system. Poor quality pipes can lead to leakage and breakage hazard, making it essential to ensure their durability and safety. To regulate quality and performance, BIS has developed a standard IS 13592 which outlines the necessary taste and specifications for this pipe. IS 13592 establishes strict standard for material composition, mechanical property, and dimensional accuracy to ensure the long-term performance of PVCU pipes. This ensures that pipes remain structurally sound during handling, installation, and use, making them reliable and consumer-friendly. Adhering to BIS standard and passing this quality test ensure that the PVCU pipes are safe, reliable, and long-lasting. This not only protects from premature pipe failures but also enhances the efficiency of drainage system, reducing maintenance costs and environmental risk.
The standard classifies pipes into two major classes based on their application. Number 1. Type A pipe. These pipes are used in ventilation pipe work and rainwater harvesting applications. Number 2. Type B pipe. These pipes are used in soil and waste discharge systems. Now, let's see how PVCU pipes are tested as per Indian standard. Ensuring quality in PVCU pipes begins with checking various dimensions of pipes. The outside diameter is measured using instruments like a vernier caliper and a pipe tape. Wall thickness is measured with a dial vernier or ball-ended micrometer. In case of socket-ended pipes, diameter and length of sockets are also measured. These measurements are compared against the specified tolerance limits to ensure compliance with the standard. Accurate dimensions are crucial for proper fitment, pressure handling, and overall performance in water supply system. Pipes are also examined for visual appearance. The internal and external surfaces of the pipe shall be smooth, clean, and free from grooving and other defects. The end shall be clearly cut and shall be square with the axis of the pipe. The next test is the reversion test. The reversion test evaluates the thermal stability of the PVCU pipes by examining their dimensional changes which subjected to heat. This test ensures that pipes maintain their integrity under high temperature conditions. The test is conducted as per IS 12235. Part 5. For the reversion test, immersion bath filled with mineral oil or glycol or glycerol and capable of maintaining temperature 150 plus or minus 2 degrees Celsius is required. For the test specimen of pipe, approximately 200 mm long is cut. Then 2 circumferential marks at 100 mm apart are scribed on the specimen. Next, pipe specimen is fully immersed in the bath, ensuring it is surrounded by the heating medium. The temperature is maintained at 150 plus or minus 2 degrees Celsius. The specimen is allowed to remain in the bath for the designated duration as outlined in the standard. The time duration depends on the wall thickness of the specimen. Once the immersion time is complete, the specimen is carefully removed from the bath and allowed to cool to room temperature. After cooling, the distance between 2 scribed marks is measured, and percentage change in length is also measured. The length shall not alter by more than 5%. The next test is the stress relief test. This test evaluates pipe's ability to resist internal stresses that can lead to cracking or deformation over time. The test is conducted as per IS 12235. Part 6. For the test, hot air oven capable of maintaining temperature 150 plus or minus 2 degrees Celsius is required. The test is conducted on the full socketed portion of the pipe with at least 100 mm of plain pipe. The specimen is placed in the oven standing on its socket and kept in the oven for 1 hour at 150 degrees Celsius. After 1 hour, the specimen is removed from the oven and allowed to cool naturally to the room temperature. After cooling, the specimens shall not show blisters, excessive delamination or cracking or signs of weld line splitting. The next test is the Vicat softening temperature test. Vicat softening temperature measures the thermal performances of the materials, ensuring durability and reliability under heat exposure. It's crucial for evaluating suitability in applications requiring heat resistance and structural stability. The test is conducted as per IS 12235. Part 2. The Vicat softening temperature test is performed on Vicat softening point apparatus. For this test, 2 test specimens are required. The specimens are of ring segments cut from pipes having length of approximately 50 mm in length and width of 10 to 20 mm. After sample preparation, when the VST apparatus bath temperature reaches approximately 30 degrees Celsius, both specimens are placed in the slots and conditioned for 5 minutes. After conditioning, a 50 Newton load is applied on each specimen and the temperature of the bath is raised uniformly. The bath temperature is recorded when 1 mm penetration is achieved for each specimen. The average of both readings is the Vicat softening temperature. The Vicat softening temperature of the pipe should be more than 79 degrees Celsius. The next test is the resistance to sulfuric acid. This test ensures that PVCU pipes can withstand chemical exposure without degradation, maintaining the structural integrity and performance in corrosive environments. The test is performed on the piece of pipe having a total surface area of 45 square centimeter. The test specimen is cleaned, dried, and its initial weight is recorded. Then it is immersed in 93 plus minus 0.5 sulfuric acid solution and kept in the oven for 14 days at 55 plus minus 2 degrees Celsius. After 14 days of heating, the specimen rinsed under running water, dried, and the weight of the sample noted. The final weight of the specimen shall neither increase by more than 0.32 gram nor decrease by more than 0.13 gram. The next test is resistance to external blows at 0 degrees Celsius. This test ensures UPVC pipes can endure external impacts at low temperature, making them reliable for low temperature conditions. For this test, falling weight impact testing machine and cooling chamber capable of maintaining 0 degrees Celsius are required. The test is performed on pieces of length 200 plus minus 10 mm cut from the pipe. Now first, test specimens are placed in the cooling chamber and temperature is kept at 0 degrees Celsius for the period mentioned in the standard. After completion of conditioning, the specimen is kept on impact tester and blow is made by dropping a striker of specified mass by releasing it from the height specified in standard. The mass of the striker and height of the drop depends on the pipe's diameter and class. For pipes with an outer diameter of 40 mm or less, a single blow is applied. For bigger pipes, multiple blows are applied depending on pipe diameter. Test is conducted for minimum 25 blows and the number of blows may increase based on the number of failures. Specimens are inspected for cracks or failures after each impact. True impact rate is calculated as the total number of failures divided by the total number of blows as a percentage as after the whole batch had been tested. The TIR should not be more than 10%. The next test is the tensile test. Tensile test evaluates pipe's mechanical strength and ability to withstand axial forces without breaking. It ensures they can handle pressure and stress without breaking. The test is conducted as per IS 12235 Part 13. The test is conducted using a tensile testing machine. The machine should have the speed of separation as mentioned in the standard. For the test, specimens of dumbbell-shaped cut or machined from the lengths of pipe in the longitudinal directions having dimension as shown on image. After that, the test specimen is mounted on the jaws of the machine and the load is applied uniformly till the time fracture. Tensile strength is calculated by dividing the load at the point of fracture by the original cross-sectional area. The test is conducted on 5 specimens and an average of 5 is taken for calculating tensile strength. Tensile strength should not be less than 45 megapascal. The next test is the resistance to dichloromethane at specified temperature. This test evaluates whether the pipe can withstand exposure to solvents without degradation. The test is conducted as per IS 12235 Part 11. For this test, a bath containing dichloromethane and capable of maintaining temperature 15 plus minus 0.5 degrees Celsius is required. For the test, a piece of 160 mm is cut from pipes. Then, the edge is chamfered from one end. The angle of chamfer depends on the thickness of the pipe. After that, the specimen is dipped in a dichloromethane bath. The temperature of the bath is set to 15 plus minus 0.5 degrees Celsius. The specimen is kept for 30 minutes. Then the sample is removed and air dried for 15 minutes. There shall be no attack observed on any part of the surface of the test piece. The next test is the effect on water. This test ensures UPVC pipe material does not release any toxic substances like lead, tin, cadmium, and mercury in water. This test safeguards public health by checking the level of toxic elements in water flowing from pipes. The test is conducted as per IS 12235, Part 4 and 10. The test is performed using ICP-MS and UV visible spectrophotometer. The test involves exposing the UPVC pipe specimen to distilled water containing added carbonic acid for a specified period after pre-washing. The water is then analyzed for a release of harmful and toxic substances such as lead, cadmium, and mercury on ICP-MS. The dialkyl tin content is analyzed on UV visible spectrophotometer. The concentrations of these substances must not exceed the limits prescribed in standard. Indian Standard IS 13592 outlines the quality and performance criteria for PVCU pipes, guiding consumers in selecting pipes having durability and safety. Thank you for watching this educational series on product testing as per Indian standards. For more detailed information, please visit our official website at www.bis.gov.in. To stay updated with the latest news and developments, follow us on our official social media platforms.